Dear friends, welcome to my video. Kindly click on the CC button for subtitles. Dark matter and dark energy are two of the most profound concepts in cosmology that challenge our understanding of the universe. Despite their elusive nature, they shape the cosmos on a vast scale and underpin much of its evolution. Dark matter is a term used to denote an invisible, non-luminous form of matter that neither emits nor interacts with electromagnetic radiation, including light, making it virtually impossible to detect directly using current technologies. Yet, it is known to exist due to its gravitational effects on visible matter, galactic structures, and the universe's overall expansion rate. Dark matter is believed to account for approximately 27% of the universe's mass-energy composition. The evidence for dark matter was first identified when astronomers, such as Fritz Zwicky and Vera Rubin, noticed discrepancies in the rotational velocities of galaxies. According to Newton's law of gravity, stars further away from the galactic center should move slower than those closer to the center. However, they observed that stars' velocities were approximately the same, irrespective of their position, a phenomenon known as flat rotation curves. The hypothesis of dark matter provides the additional gravitational force necessary to hold these fast-moving stars within galaxies, thereby solving this astronomical puzzle. Several hypotheses attempt to explain dark matter's nature. Some suggest it is composed of exotic, undiscovered particles like weakly interacting massive particles WIMPs or Axions. Others propose modifications to our laws of gravity, such as modified Newtonian dynamics MOND. Dark energy, on the other hand, is an even more mysterious entity. It accounts for approximately 68% of the universe's mass-energy content. Unlike dark matter, dark energy does not exert a gravitational pull. Instead, it is associated with the accelerating expansion of the universe. The concept of dark energy was introduced following the observations of distant supernovae in the late 1990s by two independent teams of astronomers. These supernovae appeared dimmer than expected, suggesting they were further away than anticipated. This discovery implied that not only is the universe expanding, a notion put forth by Edwin Hubble in the 1920s, but this expansion is accelerating. One leading candidate for dark energy is the cosmological constant, a term introduced by Albert Einstein in his field equations of general relativity. Initially, Einstein used this term to maintain a static universe, a concept he later abandoned and reportedly called his biggest blunder. Ironically, this blunder could explain the universe's accelerated expansion, adding an elegant symmetry to this scientific narrative. Another candidate for dark energy is quintessence, a dynamic, evolving energy field that contrasts with the constant nature of the cosmological constant. Quintessence's energy density may vary in time and space, leading to various models of the universe's future. Dark matter and dark energy, despite their names, are not dark in the conventional sense. Instead, they are dark because of our ignorance about their nature. They demonstrate the limits of our current understanding and the tantalizing mysteries that the universe still holds. They serve as reminders of how much there is left to learn about the cosmos and how it works. Future observations and breakthroughs in theoretical physics may eventually shed light on these enigmatic cosmic components, bringing us closer to a more complete understanding of the universe we inhabit. Thank you for watching my video. Kindly subscribe to my YouTube channel and give a thumbs up. Thanks for your support.